Hey there, guys. All right, so I literally just got off the plane from Houston. I was at the American Meteorological Society annual conference. I learned a lot, and it's going to take me a couple of days to kind of go through the notes and sort of process everything that I've learned. But expect several more sessions coming up here with Weather with Walks to talk about all the different things that we've learned down there in Houston. Some amazing science going on. So, from communication science and social science to space science. I mean, really, really cool things going on. So I'll talk about that in some later episodes. But I want to talk right now about something that happened the other day with lake effect snow, and it's about to happen again. So let's talk about it. Take a look at this. This is from about a year ago. This is from the National Weather Service and the Radar Scope app that they put on there. And you can see, look at the lake effect snow here from this image. These are called vortices, M-I-S-O, vortices. They're very small little areas of low pressure, if you will. And you can see them developing with the lake effect snow band. Now, before I get into what causes it, let me flip over here. Now, take a look at this. So let me go right here to the forecast. This is the HRRR model. And look at this. So this is the forecast for early Friday morning. This is about the forecast for 6 a.m. Friday, January the 30th. What do you notice on here? See the vortices? Isn't that cool? That the model is actually picking up on these vortices. So, couple of notes. Number one, these vortices can cause enhanced areas of snowfall. Okay, so we may get a couple of inches if they make it on shore. And I'll just show you this model as an example here as to kind of what they do is after it gets on shore, it'll kind of fall apart. But I think right along the lakeshore, we might get a couple of inches during the morning commute because of the lake effect snow. But you might be wondering, how do these form? And I think that's really is what is intriguing to me, to be perfectly honest. How can these things form? And I'll just kind of give you the quick science behind that. So lake effect snow forms when you have relatively warm lake water and cold air above it. And I can tell you because I just flew over Lake Michigan a couple of hours ago, and there's not much ice on the lake. There is a little patch of ice just offshore, but then the lake is wide open. So there's not a lot of ice on the lake. Why does that matter? Well, as the wind blows across an unfrozen lake, it's picking up the moisture. If the lake had significant icing on it, you would not be able to get that moisture to be picked up and lake effect snow to form. So you would not get these lake effect snow bands if the lake was significantly frozen, which it is not right now. So that's number one. You get the instability from the temperature difference between the lake and the air above it. Then you get what's called a fetch, which is the wind blowing across the long part of the lake. So you have to have the wind blowing across enough of the lake to pick up that moisture, the unfrozen lake to pick up that moisture. Okay, so that's step number two. But that's a typical lake effect snow band. But there's got to be something else to form, well, these little vortices, right? So what is that? Well, that's something that's called HSI, horizontal shear instability. So let me dive into that quick. Wind shear, you've probably heard of that before. Pilots especially look at wind shear, but we look at that in meteorology because it really affects storm growth, thunderstorms in the spring and summertime. Wind shear is really important for the generation of hail and for thunderstorms in general and tornadoes. But in this case, in the lake effect snow event, these are called vortices because they're very small in area, but they develop along this horizontal shear. So you can think of this as the wind as it is going up in height. So as you're looking up, the wind direction and or wind speed, the wind direction is either changing as you go up or the wind speed is changing. So that we call that speed shear. The other one is directional shear. When you get either of those wind shear processes, the air comes together and converges. So you combine that with the instability caused by the lake temperature difference, the fetch coming in off the lake, then you add these HSIs, or horizontal shear instability, you add the HSI into that, that is what is creating, that third step there is what is creating those vortices. So it's so cool to be able to pick it up on radar, pick it up on satellite, and you might pick up a couple of inches of snow if everything comes together, if it holds together on land. So there's your little science lesson for the day. Have a great night.